So in the calculation, you see the current is 600 milliampere. Okay, and as I mentioned in the experimental part, it is 600 milliampere. You will run it for the 5 minutes. So 5 minutes means 300 seconds. Okay, so total number of charge you supply is current multiplied with the time. So whatever the number you will get, that coulombs. Okay, that is the coulombs. But we know that 1 electron equivalent to this charge, this coulombs. 1 electron means this coulombs. Try to understand. This is the amount of the total charge you supplied, and this is the charge of 1 electron. Okay, so number of electron transferred. So this is the total number, this is the one. So suppose one banana price is $5, okay, but you paid 20,000. Okay, how many banana then how many banana? You will divide it, this divided by this. Okay, so the total charge divided by the electron. Okay, so then you will get the number of electron transferred. But 1 copper can transfer 2 electron. Try to understand. 1 copper can transfer 2 electron. So what is the number of copper? To find out the number of copper transferred, the copper ion form, you have to divide it by the whole things by 2. Then you will get the number of copper ion. Okay, number of copper ion. So I am actually giving for the first trial, but you will do for the first trial, second trial, third trial, fourth trial. Then you will do the average. Okay. So, but for the first trial first trial calculation. So mass loss of copper 0.057. You saw it in the experimental. I put it 0.057. So mass loss of copper is 0.057. So number of moles of copper is equivalent to the mass loss divided by the molar mass. You can find out what is the molar mass from the book. It is written. So that is the x2. What is the x2? That means I just put the number of moles of copper is the x2. Okay. So number of moles of copper, you got it. Okay. So this number of moles of copper contains this number of ion, this number of copper, right? This is what whatever the mass of loss of copper is, means it becomes copper ion. So that copper ion, this is the number of moles and this is the number of copper ion. Okay, so the x2 moles of copper contains y1 of this y1 number of copper. So 1 mole contains what? So you will get a number, big number, which will be very close to the Avogadro number. Okay, so do for 3 trials and take the average. So suppose whatever the value you will get it here. Okay, find the percentage of accuracy. How can you do that? The obtained result, this is your obtained result, divided by the standard result, that means 6.022 into 10 to the power 23 and multiplied with the 100. That is the percentage of accuracy, how perfect your result is. Okay, and the post lab questions I will give you, and how I will distribute the numbers I will give you in your email. So thank you, I wish you all the best, and see you again on the next lab class. Stay safe and try to, whoever just didn't submit your lab report, please send your lab report on time. Okay, thank you, take care.